Hello everyone, welcome to our 19th virtual classroom seminar. Today's topic, move to Oracle Database 23 AI, and especially everything you need to know about Oracle Multitenant. In case you wonder why this is part 1 only today, we have so much to talk about that we split it up into 2 seminars. Let me introduce today's speakers. With us today is our VP, Roy Swanger. Roy works out from the East Coast of the United States and heads not only the database upgrade, but also the utilities, including data pump and SQL loader development, plus the patching in Oracle. Then it's myself, Mike Dietrich, product manager for database upgrades, migrations, and patching in Oracle for quite a longer while. Then we have Daniel, working out from Copenhagen, Denmark, and taking also care on AutoUpgrade, all sorts of database upgrades, migrations, and of course patching and data pump as well. The same applies to Rodrigo, who works out of Rio de Janeiro in Brazil, also senior principal product manager for database upgrades, migrations, and patching. And then there's also Alex, who works out of the US from Dallas, Texas, and also a distinguished product manager for database upgrades, migrations, and patching. You find much more about ourselves and all the things we deal on a daily basis with on our blogs. So watch out, mikedietrich.de.com, dohdatabase.com, Daniel's blog. Then there's Rodrigo's blog, dbarj.com.br, but Rodrigo blogs, of course, not only in Portuguese, but also in English. And Alex's blog, alexsabala.com. And in case you need to contact us via email, you find also our email addresses here on this slide. Slides, where do you get them? As usual, we make the slides available, and they are already available on our blogs. So on Daniel's blog and on my blog, you find the slides in the slides download section to download as a PDF. In addition, if you feel you need more, or this is not the only topic you would like to learn more about, then we have more than 35 hours of virtual classroom seminars available on the Upgrade blog on mikedietrich.com/videos. And when you click on the links to the seminars, you will be directed to a YouTube video. And below the video in the description, you find always also each individual chapter. So you don't have to mow through the entire seminar if you're just looking for an individual topic. Plus, when you click on the pictures, you get access to the slides associated with each of the webinars. In case you watch part 1 today, we hope to welcome you also in part 2 in about a month from now on. So on June 27th, we'll offer you the second part of today's seminar. And again, you can chat throughout the entire seminar with us, ask your questions and such. So everything you need to know about Multitenant Move to Oracle Database 23 AI Part 2 will be broadcasted on June 27th. And with this, I hand over now to Daniel for a start. And Daniel, you take over, please.
Thanks, Mike. Let's talk about the multi-tenant architecture. Some of you might know it already. For others, it might be completely new. So we will start from scratch and work our way through it. The multi-tenant architecture is not new anymore. It's actually been more than 10 years since we introduced the first version of Oracle Database to support the multi-tenant architecture. That was in 12.1. We greatly enhanced the multi-tenant architecture in 12.2, and then enhancing again in 18 and 19. And nowadays, the multi-tenant architecture is the foundation for our autonomous database offerings, and other pieces of Oracle software like the NetSuite application runs in autonomous database with multi-tenant underneath, and we have thousands and thousands of tenants using that architecture. So I think it's fair to say that we have battle tested the multi-tenant architecture. We know that it can do the job. So as of Oracle Database 21c, the multi-tenant architecture is the only supported architecture. Once you upgrade beyond 19c, if you have a non-CDB database, you must also convert it into a pluggable database. Your non-CDBs will not work beyond 19c. So if you have an application or a database which you cannot move to multi-tenant for whatever reason, you need to stay on Oracle Database 19c. It is the terminal release to support the non-CDB architecture. And I can tell you with all honesty, there is no secret underscore parameter. There is no event. There is no switch in the database that you can toggle, which will allow non-CDB databases beyond 19c. It simply won't work. It is multi-tenant only. Our next long-term support release is Oracle Database 23 AI. Once you start to look ahead and plan for the future, the next long-term support release where you want to move your production databases, that'll be 23 AI. You can upgrade directly to that release from 19c and 21c. If you're not already on multi-tenant, then you need to put in a migration as part of the deal. Very basic. With the multi-tenant architecture, we allow the Oracle database to function as a container database, which can serve additional pluggable databases. Your application, your data goes into pluggable databases, and the root container, the multi-tenant architecture, handles everything underneath. For most cases, you don't need to change your application to use the multi-tenant architecture. Perhaps 99% of all applications will just work without any changes. Connecting to a pluggable database in the multi-tenant architecture is pretty much the same as in the non-CDB world. You have a connect string, you go via the network, you connect to a listener. The listener will hand you off to the database instance where you can do your selects, your update, your delete, your PL SQL, and all the other usual stuff. There might be a few commands which behaves differently, but for the majority of the cases, it's completely transparent to the application. You can use multi-tenant in two flavors. The most simple approach is the single tenant architecture, where you have a container database with just one tenant, just one database. You can use that in Enterprise Edition and Standard Edition too. It doesn't require any additional license. But really, to get the best benefit out of multi-tenant, you need to go into a multi-tenant configuration where you start to add more pluggable databases into the same container database. As soon as you move beyond 3 user-created pluggable databases, you need an additional license for the multi-tenant option. But you can still use multi-tenant with up to 3 PDBs on Enterprise Edition and Standard Edition too. If you don't have the multi-tenant option, I strongly recommend that you set the max PDB parameters in your database to 3. This will ensure that the database doesn't create any more PDBs than you have a license for. So stay safe and set the parameter. To start with multi-tenant, we need to create a container database. You always create a brand new container database, or if you're already on multi-tenant, you can clone an existing container database. You cannot convert a non-CDB into a container database. That won't work. You create a new one, either with create pluggable database statement or the DBCA. When you create a new container database, it'll always have the root container, which is the foundation of everything. And then we have the seed container, which we can use to provision new pluggable databases. To put your data somewhere, we need to have a pluggable database. Either you create a new pluggable database from the seed container, or you can clone existing pluggable databases, or you can take a non-CDB and convert it into a pluggable database. And we will go over this in the webinar. Now, it might seem appealing to put in your own application changes to the seed container. When you provision a brand new database, you might have some corporate standards for some objects or configuration that you want. But don't put it into the seed container, please. Be very cautious about making any changes to the seed container. If you have some common changes, we will talk about commonality later on, or for some more advanced cases, you should look into application containers, which is out of scope for this webinar. But be cautious when making changes to the seed container. When you connect to the container database, there's a view called $containers. It gives you an overview of all the containers that you have in your container database. You will always see a row with con ID 1, container ID 1, which is $root or the root container. You will always also have a row with con ID 2, which is $seed or the seed container. This is an empty PDB that we can use to rapidly provision new empty pluggable databases. And then when you start to create your own pluggable databases, we will assign them with con ID 3 and then above, and you can create as many as you want. If you connect with SQL or SQL+, you can use the show con ID command to see which container am I currently connected. In this case, it shows 1, so we're in $root. We can also see that from the alt session command. If we then move into a different container, there is another function that we can use to return the con ID. If you're connecting through odp.net or JDBC, you don't have to show con ID command, but you can use the syscontext function to also get the con ID that you are connected to. So when you initially connect to the root container, we can see with the alt session command that we can switch to different containers. But a transaction, when you start a new transaction, that transaction belongs only to one container. You cannot have a transaction that spans multiple containers. If you try to do that, as soon as you do DML in a second container, the database will throw an error and say, sorry, dude, no can do. I will now hand you over to Roy, which will take us one step further into the multi-tenant architecture.
Well, thanks, Daniel, for giving us that overview of how the CDB architecture, the multi-tenant architecture, works at the macro level, where you have pluggable databases and container databases as entities kind of playing together. But how do we actually implement that underneath? And how does that affect you when you're using or managing a container database with one or more pluggable databases? Well, the start of that is to understand how the dictionaries are integrated, and that the multi-tenant architecture implements data dictionary separation between each of these entities. So what do I mean by this? Well, in a non-CDB, you have the kind of core database, and then you have all your data tables. So in those tables, you have the Oracle maintained tables that you know and love, such as your source dollar, your user dollar, all of those kind of system tables that are at the heart of your $$ views that you might query, like $$ session. All of that is what we collectively call Oracle maintained tables and views. But you also have your user tables. These are the things that your application might need to operate or get installed with that packaged application, or the tables that your users create themselves. All of that lives in the database, and you have that in the non-CDB. And if you have multiple non-CDBs, then you have multiple copies of that data dictionary. And for all of those system tables, you're going to have an entry in tab $. In every one of those databases, you have an entry in tab $for a given system table, like sys.trigger$, for example. And likewise, in obj$, you're going to have all the Oracle maintained objects there, your packages, your views, and so on, duplicated across all of your fleet of databases. Now let's contrast that to the multi-tenant environment, where you have one container database and multiple pluggable databases. In the root, we of course have tab $, just like you would have in any database needs a data dictionary, and it's going to have those Oracle maintained tables, and those live in the CDB root. Now the PDBs have their own kind of version of that. However, The common aspects of that are maintained via metadata links. So you don't necessarily have a physical copy of source dollar or of the listing for trigger dollar in every PDB. You have a pointer down into the root where that table is maintained for the entire container and all of its PDBs. So what this means is we're able to deduplicate elements of the data dictionary and have some of them accessed only by reference. Why do you need, for example, a copy of the DBMS data pump PL/SQL package in every database when you can have one copy in the root and just pointers to it from every PDB? If you think about all of the PL/SQL packages that we have in the database, that's a huge savings of space. It can also be a lot faster to do patching and upgrade of your individual PDBs because they have less stuff in the dictionary. One of the aspects of performance of patching and upgrade is how many items are in your dictionary, how many objects are there, how big are the tables that we have to query. And if a lot of that actually just lives in the CDB root, then especially when you do an unplug, plug, and upgrade or patch, it becomes much faster, on the order of at least 20 to 25% faster for a PDB than it is as that same database as a non-CDB. And with all of this metadata stored in root, then it just becomes less work to patch and upgrade because you can patch many as one. With one patching operation, for example, data patch will run on the CDB root and all your PDBs and get everything done with one command. Now, in order to make all of this work, there's an extra layer of hierarchy in your CDB, in your CDB dollar root, where think about it in those system views that you use. Like if I'm a user, I have user tables. It shows me my tables. Then there's all tables. Maybe that's all the tables I have access to. If I'm a privileged user, I might see even more by looking at DBA tables, which would be all the tables that a DBA could see in my database. But because we have dictionary isolation in the multi-tenant architecture, we might at times want to be able to see everything across all containers in this environment. And that's where the CDB views come in. So a level of hierarchy above the DBA level, you have things like CDB tables, which would list all the tables in your entire container database and all the pluggable databases. Now, of course, you're going to have duplication of tables across multiple databases, especially if you're, say, a SaaS provider where everyone has the same schema layout. So how do we differentiate there? We have the con ID column in all of our system tables now, and that stands for container ID. So the container ID will identify the pluggable database or CDB root in which an object resides. So for example, if you select from user objects, all objects, or DBA objects, then you're looking at what is local to that pluggable database or container. But if you do a select from CDB objects, then what you're going to see is the list of objects for the entire container. But there's some tricks to this, so we'll get to that. So this applies to all your dictionary views, and there are lots of them, hundreds of these dictionary views that have now the CDB version of the DBA views, as it were. So what happens if you go to the root, and that means you have to be a privileged user to access the root, and you look at all of the table spaces that are in your database? Well, what you're going to see there is a list of table spaces, each identified with a container ID, because every PDB has its own system, sysaux, for example. But the container ID 1 is always CDB root. Container ID 2 is your PDB seed. Now, your PDB seed is not visible in these views by default, but we'll get to that much later in the talk today. And then the container ID 4 in this case is a user pluggable database, an application PDB. So if we go now to PDB 1, where we're in the context of just that pluggable database, even as a privileged user, and we issue that query looking at tablespace name from DBA tablespaces, what we will see is only the tablespaces that apply to my pluggable database. So as a DBA, you get a lot of access and ability to monitor from the CDB root context. You can look at what's going on in every pluggable database, but the users within an individual pluggable database can't see what's going on elsewhere. So a PDB never sees information from other PDBs. And when we say never, that's true even if you're a privileged user. So if you go into the CDB root, again, you have to be a privileged user to do that, and you select count star from CDB objects. In this case, we've got something over 100,000 objects listed there. But if we then, with that same user, go inside a PDB, we see a much smaller number of objects. And here's another little hint. Some of those objects are going to be pointers to objects in the root. So even though we're looking at the same view with the same user, context really matters here. What you can do at the CDB root is different from what you can do from within a pluggable database. In fact, there are going to be some operations that are not allowed in one place or another. And that's why you see the different number of objects in the PDB versus the root. Now, you can have objects that are common across all of your pluggable databases and the root. That's what we call common objects. And there are certain types of objects that this might be really useful for. Some of them are also things that you would do in an application container, but application containers are a slightly different topic that I'm not going to get into. So let's look at this example. We're going to connect to the CDB root, and if you're going to create a common object, you have to be connected to the CDB root. And we create a user with this funny C ## prefix. That prefix makes that user a common user, which means it would be available throughout all of the containers. Now, we've just created that user, so they don't have any privileges per se, but they would exist in all of the containers. Then we can go and grant the privileges we want to this user. In this case, an ops user, we want them to be able to create a session in any container. Now, you already have a couple of common users. Sys and system, for example, are common users all the time, but you don't want everybody connecting to your database as sys or system if they need to access other pluggable databases. So that's one reason that you would create these common users and then define the privileges for them and the containers that they can access. So in this case, we create a pluggable database. After creating this common user, we open it and we can connect to it as this common user, and that common user has the privileges we've granted to it. Now, there are other things you can define as common, and many of them are the things that you would need for a common user. You might want a common user profile that has the basket of privileges or roles that you would want for those users. So you can have roles and profiles. You can create common users. You can create a common audit configuration so that you don't have to have a specific audit configuration defined for every PDB. And then there are other objects that would only be in application containers. So why would you do this? Well, you might want to have users that can monitor and maintain all of the different pluggable databases so that you don't have to have a separate administrative user for every PDB. And with that, you can also create better self-service functionality by having common users that give that self-service application or environment the ability to do things like provision or monitor or manage and so on without having full DBA privileges. You can also have separation of responsibility, or what we call on the slide here, separation of duties. Maybe you have a security admin on one hand, which needs one set of privs, and a application admin on another that needs another set of privs. And you want to use the principle of least privilege to give each of those users only and exactly the privileges they need, while still letting them access all of your containers. So system is going to be too powerful for that. But if you create a common user, you can have that apps admin able to administrate the application across all the containers in the pluggable database, while the security admin is maybe handling your auditing configurations. So a lot of good reasons to use these common users. Now, I mentioned that prefix, it's C ## as the common user prefix. And you can change that technically. You could make it common underscore or whatever you wanted to, but we urge caution in that because we've seen some issues if people use a common user prefix where in some contexts it might confuse whatever elements of the system or scripts or applications are present. So C ## is your baseline default common user prefix, and I would just go with that unless you have a truly compelling reason not to do so. It's also a good idea, if you have multiple container databases in your environment, to have the same set of common objects across all of those databases. That way, when you unplug a PDB from one container and plug it into another, it has the same kind of meta environment around it. Just like you would expect to find the system user in any Oracle database. If you're using these common users for administrative purposes and such, then that PDB is probably going to expect that common user to be there. So make it as uniform as possible. And that's a good principle for all of your database environments. Uniformity really helps make it easier to manage. Now, directory objects are a little different here because there are some directory objects that are supplied by Oracle, and one of them happens to be owned by my team, the Datapump team, Datapump Dir. Now, let's consider the case of having a bunch of pluggable databases, and you want to be able to export, and you want to use that default location. So we go to a pluggable database PDB1, and we look at the definition of Datapump Dir, and you see the directory path with this kind of alphabet soup at the end, which is actually, it's the GUID, the global user ID of that particular PDB. So that is how we are looking at the directory object for this particular PDB, even though it is a common object. In some ways, you'd think of it as a common object. It's Oracle supplied dictionary object, but it's going to be different for every pluggable database based on their GUID. And that makes sense because you don't want all of your pluggable databases necessarily to be able to see what everyone else is doing. Remember, we've done all this work for dictionary separation and isolation in order to provide the security there. Why would we mess that up by having PDB2 able to see the dump files produced by PDB1? So by default, we don't do that. So if you then try to change that, you're going to find that you can't. You can't change it from within a pluggable database. So because it is an Oracle supplied directory object from within the pluggable database, it's going to remain the same. And that's true even if you tried to drop it and recreate it. So the moral of this story is, if you want to have, say, a common directory for all your Datapump dumps, or a common location for any Oracle supplied kind of directory, create your own directory with a new name. And then instead of saying, the default directory being Datapump Dir, on every Datapump operation, you could say directory equals mydir, and however you've defined mydir, we will use that. It's very simple, and it provides you that extra level of security and control that you would want in your environment. PDBs do share the CDB root, and by default, they would have all of the same parameter settings as the CDB. But of course, if you've consolidated a whole bunch of different PDBs with different applications and different usage patterns, you might have need for different parameter settings, for example, like optimizer setting here or some other resource management setting there. And there are some parameters that you can change from within a PDB. So by default, you'll get whatever's in the root, but you can change many of the parameters that will be relevant. Now, if you want to know which parameters you can change, one way you could do that would be to query the $system parameter view. The isPDB modifiable column, if it's set to true, means that you can change that from within the context of a PDB. And as you can see, 246 out of our many hundred parameters can be modified that way. But there's actually a much easier way, or I think a better way, to find this kind of information, and that's to use this tool called AuraDiff, which we released last year. And what this does is it allows you to find out information about different versions of Oracle database. So here's a little video demo of it, where if you go to auradiff.oracle.com and you have an Oracle account, so all you have to do is your Oracle single sign-on to access it, available to anybody who has an Oracle account. What you can do is use this to compare different versions of the database in different ways. And here we're going to look at parameters here. Let's say you're on 19C with a relatively recent release update, 19.22, and you're wondering, what's going to happen when I go to 23? What changes to parameters am I going to see? And what you can see here is that we've got 74 new parameters. You see, we've got added highlighted there. But which of those are modifiable in the PDB? 51 out of 74 new parameters can be modified from within the PDB. And if you're wondering about that, like what's this max columns parameter? Don't change it, by the way, but you can if you really want to. We don't generally advise it, but you can click on that parameter. It'll take you right to the documentation and say, here's what's going on with max columns. You can learn everything you need to know, and you can start in ORADIF by doing that. You might wonder, well, what about parameters that have been removed or now obsolete, or ones that have changed? And how have they changed? Has the default value of a parameter that you set in your init.ora file changed? You can find that kind of information using ORADIF. So it's a great tool, freely available to everybody, and it is updated for every release update. It gives you the straight scoop right out of the data dictionary of everything that has changed or everything that's remained the same between two versions. Last word about these parameters is that when you clone a PDB or you unplug and plug it, it brings its parameters with it. It brings it inside the database. We don't like copy parts of the init file out of it. There are certain tables that we use to make this happen. There are going to be some exceptions. There are always exceptions. This is Oracle, right? But you will bring your parameters with you to the new location. So if you're moving to that new environment, you might want to double check your parameter settings to see whether any of them are duplicating what's in the CDB root in that target environment. Anything that is no longer needed due to, say, a different patch level, especially for those optimizer. If you've got fixed controls or anything like that, make sure you change that when, or at least look at it when you move to a new environment. So if you want to see which parameters you've defined specifically and review that list when you move, query the $system parameter view using the con ID, remember, container ID column, and you'll be able to find which ones are specific to your pluggable database. That's a lot about the data dictionary. Now I'm going to hand you over to Rodrigo to talk about not how things are isolated, but how resources get shared across pluggable databases. So take it away, Rodrigo.
Thank you, Roy. So one of the big advantages in going to the multi-tenant architecture is that you can also share system resources between different instances that now will become a single instance. So for example, when you have a non-CDB, you need to allocate a memory for it. It will also have the set of background processes like the pmon, smon, log writer, db writer, and so forth. Also the database files that it needs to read and write on. And now imagine you have 3 non-CDBs. So you would multiply that by 3, okay? But now, what if we consolidate those 3 non-CDBs into a single multi-tenant CDB with 3 PDBs inside? Now we can only allocate the memory ons to that CDB, and the CDB will be responsible for moving that big memory that we have and distributing among the different PDBs. Also, we will only have one set of background processes, so only one pmon, only one smon, and so forth. And also the database files. So for example, we will only have one set of archive logs, not one for each non-CDB as we had before. And the same, for example, for the redo logs. Now let's see the memory distribution over the time in an example chart that we have. So this chart shows the SGA distribution over different PDBs on the same CDB. And here we can see that depending on the workload, the CDB will move and give more SGA to a given PDB over the time and then reduce it and give to another one. So this is all done dynamically. Imagine, for example, if those were different instances. Different instances, they cannot share memory between them. But now that we have all those instances on the same CDB, the CDB can, for example, if one instance needs more memory than the other at a time that the other PDB is not doing anything, it can simply reduce the SCJ here and leave a bit more there. So that's a huge advantage in going to the multi-tenant architecture. Talking about consolidation strategies, what we recommend here is don't mix PDBs with different SLAs on the same CDB. What do I mean with that? For example, don't mix production with dev environments on the same CDB. Usually they have different requirements regarding SLAs. And also don't mix PDBs that have a different maintenance window day. So for example, let's say one of your PDBs, you can turn it off on Saturday evening and the other one only on Sunday evening. So don't mix them on the same CDB because it will be very hard for you to find a maintenance window that can fit both of them, for example, for doing an upgrade or some kind of maintenance. So the total memory consumption here that we recommend is to get all of your requirements of the PDBs together and put it minus 20 to 30%. So that way the memory will flow around, and if you think that you need more memory, then you can slowly increase until the maximum memory. We will talk later on the next webinar about CPU instance caging and how resource managers kick in here to distribute the CPU among the instances. So we have an example here of a US healthcare provider that using multi-tenant, it reduces the number of instances by a factor of 7. So it had 7 less instances than before. And it reduced the number of physical servers by 50%, so half of the physical servers. And why? Because of all the memory processes and files consolidation that I just talked about on the previous slides. You can run multiple CDBs on the same host and out of the same Oracle home. So let's say, for example, you don't have the multi-tenant license that allows you to have more than 3 PDBs on the same CDB. You can have up to 4,000 PDBs in that case. But if you don't have that license, you still can have multiple CDBs, but each of them cannot have more than 3 PDBs inside. So that's possible using the same Oracle home and the same host. So now talking about consolidation, right? We have those former consolidation methods where you could have multiple applications using the same database, but connecting on different schemas, or you could also have virtual private database. But now with the PDB architecture, it's much easier to have each application running in its own PDB, because then you can, for example, if you are trying to move that application, it will be very simple to unplug that PDB and plug it somewhere else. It's like a container, it's totally isolated. You don't have anything else running on that database. So with PDB consolidation, it's less complex, it's a better isolation. You have operational benefits. You can, for example, if you don't want to batch that given PDB, you can simply unplug it from that CDB and put it in another CDB, and that's it. You will isolate that PDB in another CDB. And it's very, very easy to clone as well. We have this example of a global provider of financial services that in the past, it used to have a virtual private database to isolate different applications on the same database. It was working very well, but it was very complex. So a solution they had after the multi-tenant architecture was out, starting 12c, was to move from this virtual private database way for doing stuff to the containerization way for doing stuff, which is much more simple, okay? So they moved and they have a huge success doing that move. They reduced the complexity and now the operations are much easier. We have this many as one principle. What is this many as one principle? So if you had, for example, 3 databases that were non-CDB in the past, and you want to patch each of them, how would you do that? You would need to kick in the patching process for each of those databases one by one. But now with the multi-tenant architecture, where you have, for example, all those 3 databases in a single CDB, you can simply run it on one database, and our tool automation will be responsible for patching the CDB and then running the patching process for each of the PDBs. And that's not only for patching. That also applies for upgrading, for example, doing backups or configuring data guard. So you just do it once, you don't need to do database per database. Same applies for rack, monitoring, and many, many other operations. So the benefits of multi-tenant are many. Here we are listing 3. Self-contained PDBs, which makes much easier, for example, as I already said, to clone them, to do maintenance on them. They are common and easier operations, as we saw with the many-as-one principle. And the resource sharing and consolidation, as I showed, for example, with the memory, the background processes, and the database files. Now it's with you, Alex.
Thanks, Rodrigo. So let's talk about the CDB creation. To create a container database, you need to take care of 3 things. We call this the 3 C's. So first one is the character set, the second is the components, and the third one is the compatible. So for the character set, we recommend you to keep the default is the AL32 UTF-8, because using this character set, you'll be able to plug any character set on this container. Second is the components. So check your source database to see what's in use and install as many as you need. So no more than that. Remember, when you are upgrading later, it will take more time if you have all the components installed. For example, you have the workspace manager in one database, you have Oracle text in another database, and you have spatial in another database. So you have to create a CDB with all the 3 components. For compatible, we recommend you to use the default for the release. For 23 AI, it will be 23.4.0. So keep this default unless you want the option to downgrade. So use 3 digits only, and you don't need to change your compatible when you are patching. So remember, when you're plugging a PDB on a CDB, it will change the compatible. It's a silence and without confirmation. So changing compatible is irreversible. You cannot go back. So it might prevent future move or clone of the PDB. For example, you have this CDB on the left using compatible 23.4.0. If you are moving your PDBs to the other 2 CDBs, it's fine because the compatible is higher. So remember, this is not a recommended scenario, but it's possible. If you are moving from the CDB in the middle, 23.5.0, to the CDB on the right, 23.6.0, it's fine. But if you need to move to the CDB to the left, it's not possible because the compatible is lower. So keep compatible at the same setting in all CDBs on the same release. There is one underscore parameter we recommend you to set to false. Is the exclude seed CDB view. So this parameter, when you are creating the CDB views, you see the container ID number 2 is the PDB seed. So when you are patching or doing upgrade operation, it's good to see the PDB seed, because if you have any issues, you can see first before it moving forward the errors when you are creating a new PDB from the PDB seed. So, Roy, please guide us through the migration process.
Alex. That was awesome. And I think everybody now can create your container database and get started with it. Now, getting started with it might mean, in some cases, creating a new PDB from within that container database. But more often than not, you're going to be trying to migrate a non-container database into a PDB. And that's what we're going to talk about now. And it's important to note that I use the word migrate there. This is a migration that involves downtime, and it involves running a script that you'll only have to run once in the lifetime of your database. That's the script to convert from a non-CDB to a PDB. If you want a low or no downtime migration into the multi-tenant architecture, the only way you're going to be able to do that is using Golden Gate. So the process of migration is really, you should think about it as two phases. One is the plugin, and the second is the conversion to the PDB architecture. So the plugin part, what we're going to do is we're going to first check whether this non-CDB will actually successfully be able to be plugged into that container database. And we'll do this by generating a manifest file for your non-CDB that lists all the things of interest when we are going to convert it to a pluggable database. Then we can use that manifest in the container database to say, okay, if we try to plug in this non-CDB, is it going to work? Pretty simple process here. You just use the dbms pdb.describe procedure to generate your manifest file. You have to give it the name of an XML file. That's the format of the manifest. And what's in there, you can look at this. You're a human being who can read markup, right? So you can see that it has the physical properties of what are the data files, what are the components installed in this database, what parameters are set, and so on. And then we can check this against your container database to see whether you can actually plug this in. Now, this will give you a yes or no answer in this case, but you might need to, well, you always need to look at the details in the PDB plugin violations view, because there are some things that would disallow you from plugging into that container database. For example, if you look at the warnings down there, it's a good thing that they're just warnings, because what you're going to do here, it's saying that your database you're plugging in had a compatible setting of 12.2 and the CDB is 19. So it's good to know that anytime you plug a PDB into a container database, it adopts the compatible setting of the root. So the second you plug this in, it's going to go to compatible 19. If it had been reversed, if you were trying to plug a database that had compatible at 19 into a CDB that had compatible 12, then it would be an error. It wouldn't be possible. Other things like components can be an issue. If you have components in the PDB that are not in the root, that would be an error condition. Other times, though, you get a warning, which is pretty straightforward. It says the PDB plugged in is a non-CDB, and you have to run non-CDB to pdb.sql to convert it. So reading and understanding the entries in the PDB plugin violations view is very important when you're plugging in to a container database. So always check that for any plugin operation. That's true of a non-CDB going into a PDB, but also if you do an unplug and plug of a PDB from one container to another. You may think you know that both containers are the same, and then you'll find out, oh, wait a second, they had a different character set or a different time zone version or a different compatible setting or something like that. If you have one of those errors, then you won't be able to open the PDB. Simple as that. So with the plugin, after you've checked the compatibility, now you perform the plugin, which means shutting down that non-CDB. You can't plug in and open non-CDB, and now you plug it into the container database and it becomes a PDB. So you shut down immediate, start up in read-only mode, or alter it to be read-only, generate your manifest, make sure it's as current as possible, always a good idea, and then you create the PDB from that manifest file. So this is one of those many forms of the create pluggable database. This is the one where you say using an XML file, and it plugs in your non-CDB as a pluggable database in this container. So that's step one. It's pretty easy. And until that very last bit where you're shutting down and plugging in, it can be done online. All that checking of compatibility, that can be an uptime event. But once you want to do the plugin, now you've shut down the database, you plug it in, but it's very fast. Now, however, we need to do the conversion. And what that means is running non-CDB to PDB.SQL. It's faster than it used to be, but it still will require some downtime. The reason for that is it is going into your data dictionary and kind of rooting out all of the things that are now going to be metadata pointers into the root and converting them from those physical entries into those metadata pointers. It may also do other things to line up your PDB with the CDB root, such as raising compatible for the PDB. So this is an irreversible operation. There is no script for PDB to non-CDB.SQL. The only way to go from a PDB to a non-PDB is to use data pump or transportable table spaces. So in order to do this, you open that pluggable database, you set your context into that container, and then you run the non-CDB to PDB.SQL script. That will spew lots of stuff onto your terminal window. You can watch it run if you want to, and at the end, close it and reopen it, and all should be fine. So that's the process. Now, you should still check PDB plugin violations to make sure that any of the previous warnings or errors have now been resolved by this process. Remember that warning that said this was a non-CDB and you need to run non-CDB to PDB.SQL? Well, if you run that, then you should not find that warning present and unresolved in the PDB plugin violations view. And then also check the open mode. Make sure that it opened read, write, and not restricted. So make sure it's not open in a mount state or something like that. Now, another thing you can do then is to set the default state of your pluggable database. Now, this is something you didn't have to do for a non-CDB. When you start up a database, a non-CDB, you start it up. However, in a container database, because you might have multiple pluggable databases all consolidated into one container, we don't assume that you want them all started up every time you start up the CDB. You might have a pluggable database that sits there idle most of the time, and then at the end of the month, you just load a bunch of data into it for archival purposes. And maybe the default state of that one would be, it will be closed by default. So this save state operation tells us what is the state that you want by default for this PDB when the CDB starts up. Do you want that PDB opened automatically, or do you want us to just leave it closed? So here's a little demonstration of migrating manually from a 19C non-CDB into a pluggable database. So we're going to start in our 19C database and create that manifest file using dbms pdb.describe. Very quick. You saw it less than half a second there. Then we can go into our container database and run that code snippet that you can copy and paste off the earlier slides. And is it compatible? Yes, great. So no problems, right? Not so fast. Let's check the PDB plugin violations view. And we do see a set of warnings here. So good, no errors. That's good. And maybe those warnings will get taken care of during the migration process. So now we're going to do the plugin. We shut down, and then we start up mount and open read only for the database. We again create that manifest file because you just never know. What did some user do in the 5 seconds between me showing you one manifest and the other? Users can do all sorts of things. So now we create the pluggable database using that XML file. And in this case, we're not going to copy the data files. It's a very quick operation, creating a pluggable database, 1 second. Isn't that awesome? 3 seconds. I said it was downtime involved. Well, where's that downtime come from? It comes from non-CDB to PDB.SQL. And as you can see what's going on here, it's going through the dictionary, it's recompiling invalid objects, it's setting a whole bunch of things. And now once that has finished, now we close the database and we reopen it, and we check PDB plugin violations to make sure that there are no latent unresolved issues. We check the open mode. It is open read write. It's not restricted. Everything good, everything smooth. And now we have a pluggable database that will open automatically when we start up the container. So that's the manual approach to doing that non-CDB to PDB conversion. We'll show you a much more automated approach later on. Last bit on migration to multi-tenant. the question that is on everybody's mind when the first time they approach this is, how long is this going to take? How much downtime do I need to convert my database to a PDB? And the answer, it depends. It's Oracle. The answer is always, it depends, right? But in this case, we can give you a range. It's typically somewhere between 10 and 20 minutes by the time you do all of this. It really depends most on the dictionary complexity. You saw in the example earlier when I was looking at the architecture, an individual PDB had about 24,000 objects in it. The CDB with the root and seed and the PDB had 100-some 1,000. I know customers that have 23 million objects in OBJ dollar. On that, it's probably going to take more than 20 minutes to run non-CDB to PDB because all of those queries that we're running in the dictionary and all the updates we're making are on tables in that case that are really huge. So it's mostly about dictionary complexity. It has nothing to do with the amount of data in your database. The pre and post tasks, just make sure you do it right. Don't skip anything there. Do not skip PDB plugin violations under any circumstances. You may think you know what's going on, but how often are we surprised by what's in our database, what a user has done, or maybe what even some other DBA has done? And then for DataGuard, there might be some additional steps, and we'll talk about those a bit later as well. So the total downtime that I would suggest you budget for a migration into multi-tenant without Golden Gate is on the order of 1 to 2 hours. It's a migration. There are pre-tasks for your applications and post-tasks, and you're going to be dealing with how do I connect to this later because now I've got a CDB that has its own SID and the PDB is within that and it has a service, but there's lots of stuff to think about. So don't rush it. Make sure you know what you're doing and set aside the time necessary to make it happen. So that's the manual way of migrating into a PDB from a non-CDB, but there are lots of other options. We would be remiss if we didn't tell you about all these other options for different amounts of downtime or complexity or edge cases. So I'm going to hand you off now to Rodrigo, who can talk about doing a plugin, no copy versus copy. Take it away, Rodrigo.
Thank you, Roy. Now let's talk about some migration options to go to the CDB architecture. And let's start with the most classical one, which is the plugin NOCPY. So how does it work? So the plugin NOCPY, you have your source non-CDB database and its data files. And the first thing you have to do is put it in read-only mode. Why? Because we need to access the dictionary to generate the manifest file so we can use that manifest file to later plug in this non-CDB into a CDB. Okay, so again, set it to read-only mode, and you run dbmass pdb to create that manifest file. Now, with this manifest file in hand, you shut down your source database, you connect to your target container database, and then you run your create pluggable database with this no copy clause. This no copy clause will read the manifest file, see all the list of data files, and will straight plug in this non-CDB as a PDB in your target container database. Okay, so it's gonna simply plug in and reuse the existing data files. And the first thing we note here is that as we are reusing the data files, it's not possible to roll back because we are using them. If you want to go back to your previous scenario, you need to do a restore and recover operation to rebuild your source data files. How do we do that using AutoUpgrade? So with AutoUpgrade, you simply specify what is your database, what is your source home, target home, and where do you want this database to be plugged in. So here in this example file, we see that we are using AutoUpgrade, but we are actually not upgrading anything. Here, the source home is 19.22. The target home is 19.23. So they are on the same release. We are not doing any upgrade. But that's a side effect of AutoUpgrade. You can also use AutoUpgrade for patching. As this case, we are patching from 19.22 to 19.23. And also converting from non-CDB to the PDB, leveraging in all the robustness that we have in the AutoUpgrade tool. Okay, so you prepare this config file, and then you simply call AutoUpgrade. This is much easier than performing all the steps manually of shutting down your database, putting in read-only mode, create a manifest file, do the create pluggable database with the NOCPY clause, and then doing all the further steps. So with this, it's much easier. But of course, you can also use AutoUpgrade for upgrading, right? So in this example now, we are using AutoUpgrade, but not from 19 to 19, but actually from release 19 to release 23, okay? Let's see a demo of this working with AutoUpgrade. So here, first, I show the environment. We have this DB19, and I will connect on this instance. And just to show that this is a non-CDB database, and the release is 19.19. So this is the RIO level. And I will call AutoUpgrade with the minus version parameter, just to show that this AutoUpgrade version is capable of going to 23. Now I prepare the config file. I want to upgrade this DB19 from this home to the 23 home. And I will call AutoUpgrade with the mode analyze. So now I check the status of my AutoUpgrade job, and the job finished. Let's take a look on the status.log file to see how it was. So take a look on the log, and here is a surprise. It failed. And why it failed? Because that was a non-CDB 19. And I cannot go from non-CDB 19 to non-CDB 23 because there is no non-CDB in 23. So actually what was missing is that I need a CDB 23 to move this non-CDB 19. So what I do, I add on my config file that my target CDB will be this pre-created CDB1, which runs on release 23. Now I run it again with mode analyze, and checking the status, the job completed. And now if we take a look again on the status.log, we now see that the analyze phase was a success, no manual intervention needed. Now we can simply call again AutoUpgrade in the mode deploy and wait. So here I put my AutoUpgrade to show the status every 30 seconds, but I'm speeding up the things here, otherwise we would need a couple of more minutes. So here we see it's running UTL recompile, non-CDB to PDB conversion, and finally the job completed. So now I connect in my CDB1, which is the release 23 database. And we have a container named DB19, which was that non-CDB from version 19, now converted to a PDB and upgraded to version 23. So we see how simple it is to do that task of converting and upgrading with AutoUpgrade. You can also use the move clause instead of the NOCPY clause. And both options are very fast because it's just a relink on the OS level. It's not gonna duplicate your files. It's just a relink on the file name. And this move option is also good because we'll keep your database file names under the standard pattern. So also use file name convert clause if you want. Now let's talk about the plugin copy. That's the second method we are gonna show here on this example. So the plugin copy, it's very similar to the plugin NOCPY. Again, we have our source non-CDB. We need to put it in read-only mode so we can read the dictionary. We create the manifest file, then we shut it down. And after we shut it down, we go to our destination CDB, so our target container database, and we run again the create pluggable database, but now with the copy operation instead of the NOCPY. So what the copy operation will do is read the manifest file, will find all your source database files, and will now duplicate them. And of course, this can take a lot of time depending on the size of our database. So the copy operation, of course, will copy all the data files, okay? And the first advantage we see here is that your source is preserved for rollback. So even though now your maintenance window is bigger, the side effect is that now you have a rollback environment and your source database is preserved and untouched. How do you use this copy operation mode? Using AutoUpgrade, you need to specify the start PDB copy option equal to file name convert and then give the file name convert clause. So you specify that, and then you simply call AutoUpgrade in deploy mode, and AutoUpgrade will do everything for you. If you don't want to specify the file name convert clause, you can put equal to none, and then OMF is gonna be used. So it's also useful for ASM, and will put your database files under the database standards, okay? The last thing is that we also recommend you to add this config file option in your config file, which is your database prefix dot close source equal to yes. And why that? Just to ensure that nobody accidentally connect on your source database after you run the upgrade process. And of course, this applies to the copy operation because your source database will be kept untouched. So in that case, we just want to make sure it's gonna be turned off after the clone operation.
Thanks, Rodrigo, for showing those two options. But in one of them, we have to copy the data files. In the other one, we lose our rollback plan. Isn't it possible to eat our cake and have it at the same time? In Oracle Database, of course, you can do that. Refreshable clone PDBs. When we use refreshable clone PDBs, we will make a copy of your non-CDB in the target container database. We copy the data files over the network, but we do that without interrupting the source non-CDB database. We then roll forward with redo. Until it's time to do the migration, we can disconnect, do a final refresh, and convert the copy of the database into a proper PDB. On your source system, you have your source non-CDB database. Somewhere else, we create a container database or use an existing one. Here we have the container database on a different host, but it could also be on the same system as the source non-CDB. It doesn't matter. We just need to be able to establish a database link from the container database back into the source non-CDB. When we use the create pluggable database statement, we will specify the database link, which then tells the container database, go over the network and take the data files from the source non-CDB. We can do that without interrupting the source non-CDB database, so we don't have any downtime yet. Even for a huge database, we can copy the data files in advance. Then we use redo from the non-CDB database to roll forward the data files on the target container database. We can do that at regular intervals. You decide the refresh rate. Here it's 30 minutes. So we will do that constantly until you say, now I want to complete the migration. At your will, you can shut down the application, disconnect users from the source non-CDB, and we can do a final refresh, bring over the very last changes from the non-CDB, roll forward the data files in the container database. Then we can cut the connection and then convert it into a proper PDB. So we could really limit the downtime here. We just need to do the final refresh. And the source, we don't touch it at all. So we have it sitting there in case something happens with the migration. How does it work? Well, in the source non-CDB database, you need to create a user and grant some privileges. In the container database, we create a database link which connects as the user we just created. Then in AutoUpgrade, you specify the name of the database link and also a refresh rate. In this case, it's 300 seconds. So every 5 minutes, AutoUpgrade will bring over the redo and roll forward the data files. Then you also specify a start time. This is when we will do the final refresh and complete the migration. So on the source database, you run AutoUpgrade and Analyze mode to see if there are any critical things. We also do the pre-upgrade fix-ups or the pre-fix-ups. And then on the target system, you use AutoUpgrade and Deploy mode, which will start the entire process of moving over the data files and so forth. So when you start AutoUpgrade and Deploy mode, we will start to create the PDB. We will bring over the data files from the source non-CDB and then roll forward with redo. At the time specified by the start time parameter in your AutoUpgrade configuration file, we will do a final refresh, cut the connection, and then turn the database into a proper PDB. And the beauty is, as I explained earlier, we don't touch the non-CDB database at all. It just sits there waiting as a fallback if something happens. I've prepared a little demo where we can see this in action. I have a 12.2 non-CDB database that I want to upgrade to 19C and also convert it into a PDB using Refreshable clone PDBs. I set the environment to the DB12 database. This is my source non-CDB. I create a user, DB link user, which I will use to connect with the database link. And then I grant the necessary privileges. I then set the environment to my container database. And I create a database link which connects to the user that I just created using an alias that points back to my source non-CDB database. And I test quickly that it works. This is the AutoUpgrade configuration file. I have the SID of my non-CDB and the SID of my container database. I specify the name of the database link and the refresh rate every 10th minute. And for the fun of it, I also want to rename the database to PDB1 and use OMF file names. I set start time to 30 minutes from now. But you could also set an absolute point in time. Then I start AutoUpgrade in Analyze mode just to check if everything is fine. It takes a little while. The job completes and I can find the details in the summary report. So let's have a look. It's a simple text file. Check passed, no manual intervention needed. There is nothing critical preventing us from moving forward with this database. So now I'm going to run AutoUpgrade in deploy mode. I'm using the same configuration file. And we can see that the first step is to create the PDB in the container database and start copying the data files. I use the lsj command to refresh and get a status every 30 seconds. But currently we are creating the pluggable database. We are bringing over the data files. Let's have a look in the alert log of the container database. I can see underneath the hood, AutoUpgrade has executed a create pluggable database, and now the container database is copying the data files. We are currently in the refresh PDB state. So we are now bringing over the redo, and we will do that for an additional 20 minutes. Now let's connect back to the source non-CDB database and create some data so we can verify that the very last changes was brought from the non-CDB into our PDB. Let's ensure that we don't lose any data. We create a table and insert the row 42. Let's have a look at the alert log again. We can see that the create pluggable database statement completed. We've copied over the data files, and now we are refreshing. We are using for and redo from the non-CDB to roll forward the data files in our container database. A little later, we are done with the refresh rate. We are ready to start. So now AutoUpgrade will do a final refresh and then move on with the upgrade. It takes a little while, so let's fast forward. Then the non-CDB to PDB conversion. recompilation, post checks and post fix-ups, some housekeeping. The job completes. Everything is done. We've now upgraded and converted into a PDB. Let's connect. Show PDBs. We now have PDB1. Remember, we renamed it. It's open, read, write, and unrestricted. All looks good. And we switch to the pluggable database, and we can see the record is there. The last changes were brought over into the PDB. A very convenient way of migrating to multi-tenant. We can hide the time that we need to copy even a huge database. If the container database is using DataGuard, you should know that the Refreshable clone feature only supports plugging in with what is called Deferred recovery. We will touch upon Deferred recovery and Enabled recovery a little later in this webinar. On the source non-CDB database, you need to ensure that the archive logs is present on disk so that the container database can fetch them over via the database link. If you have an RMAN backup job which deletes the archive log after backups, you should suspend it or change the retention policy so we have the archive logs on disk. Otherwise, of course, we cannot roll forward if the archive logs are missing. When the container database is copying the data files, it'll do it very fast and very efficiently. It'll use parallel degree based on the resources in your container database. If you have a very powerful container database and a non-CDB which is not equally powerful, you will see that the container database will put a lot of load on the source non-CDB database. If we want to limit the amount of resources that the container database can use to copy the data files, there is a parameter in the AutoUpgrade configuration file where you can decide on a parallel degree. If you don't specify anything, the container database will automatically determine a parallel degree, but it might be too hard for the non-CDB. Copying the data files into the container database, we will do that in a very efficient manner. We have developed a new method of moving files to support this new feature. You can see that in $$ session long ops. There's an operation name called kpdf something with copy task. This is when we are bringing over the data files, and it is very efficient. Now, of course, you might be interested in using this functionality to do your own copying of data files, but you cannot do this. This is something internal in the database that only the database itself can use. If you try to see underneath the hood what we are actually doing, you get some sort of obscure select statement from an $X view. So clearly this is something internal, not meant for you to use. We were very excited about this feature when it was initially launched, so I know Mike was equally impressed and he wanted to battle test that out there in the real world together with a customer.
Thank you, Daniel. That seems to be a very cool feature. But let us have a closer look whether customers really use that already. And here in this case, I would like to introduce you to a customer case and show you slides the customer showed with us on stage at Oracle Cloud World 2022 in Las Vegas. It's Zürcher Kantonalbank. They are one of the largest banks in Switzerland. They operate since over 150 years, have more than 5,000 employees, and it's a globally network service-driven bank. When I've been involved by a colleague from Oracle Switzerland a while ago, there were two challenges on the table. First challenge was customer wanted to migrate away from the big endianness architecture to Exadata. They had already some Exadatas and wanted to completely consolidate everything on the Exas environment. In this case, we used transportable table spaces, and this is not what I'm going to talk about here. The other challenge was consolidating the databases then into the multi-tenant architecture. So we proposed the refreshable clone technique for this. And we proposed also using AutoUpgrade for it. The customer was quite amazed by this idea and asked internally for volunteers. Interestingly enough, there were more groups volunteering, but we reduced it to 3 groups. 3 different databases on different servers, 165 gigabyte in size, 555 and 18.5 terabyte. It's all non-CDBs, and they run already on Exa environments. We had an X6 test environment for that, and source and target versions were completely 1915 at the time when we started that. Of course, today they are on a much higher patch level. What did we do? We created the cloning user in all the source databases and added all the required privileges Daniel showed you before to the cloning user. Of course, once you're done, you can clean it up. And then we created 3 different database links from the CDB into the 3 different non-CDBs because we wanted to run this all at the same time. And let's see how that worked. So this is a snippet or a screenshot from AutoUpgrade. So you see that all 3 databases had been migrated in parallel onto the target CDB. And on the right side, you see that the first database had been finished after 26 minutes. Now the 2 other databases, the mid-size one with half a terabyte completed in about 3.5 hours. And the most interesting one was, of course, the largest one with 18.5 terabyte that took 29 hours. Now, an important note to take here. This is not downtime. First of all, we did this for testing, so there's 0 interruption involved on the production environment. But secondly, even if we would do this for real, then the amount of downtime is only the last piece of the migration, because this is when the conversion happens after AutoUpgrade had been disconnected. So you must script your application to be stopped when this happens. And the downtime is much, much slower or smaller here, maybe 10, 15 minutes, something like that. But it was interesting to see how long it took, especially for the large databases. Now, are they successful? Well, the first non-CDBs had been migrated successfully. The project is still ongoing. They have a lot of databases to move over. But some remarks. First of all, one finding was when you migrate a really large database, make sure your archives don't get cleaned up. Typically, same, I guess, in your environments, Armin comes after 24 hours or maybe after 12 hours and starts like taking a new backup and then cleaning out the archives on disk. If that happens during the process, be prepared that you restore them again, because towards the end of the process, then we need also the archives to sync with the source environment, especially when it took so long. The second thing is a customer-specific setup. In their Oracle user profile, they have an idle timer, and the idle timer kicked in after 12 hours and disconnected a user session. So be aware of that if you have some special setups in your environments as well. And then we convinced Christian Marquardt, the lead architect at ZKB for the Oracle databases, to speak with us on stage at Cloud World 2022. What he did was amazing. And he said, look, it's very comfortable to use. It's very easy to set up. Everything happens automatically. It does not require any user interaction. It's a simple syntax. No license costs associated. It's just standard, nothing extra, nothing to install or whatever. And it's perfect also for the pre-migration tests because you can run this multiple times. And on the side, it's very, very stable. So they use this technique, as do many other customers. We have actually educated a lot of customers to use that. And it has only one small caveat. And we talk about this later when we talk about the standby topic. Now, Alex, it's your turn.
Thanks, Mike. So let's talk about other migration options. So Datapump. Datapump is the most flexible to migrate data. So you can migrate from a lower version, you can migrate cross-engine, you can migrate from any character set, and you can apply features or a partial migration. Transportable table space, it's faster for large database. You can also migrate from a lower version and do cross-engine migrations. And it also preserves the source database for fallback. Golden Gate, it's the only 0 downtime option. You can migrate from a lower version, cross-engine, and preserve source database for fallback. I will not spend too much time on this table, so you can come back later here and check the migration options and compare with your database and your business requirements and choose the best one for your environment. Best practice for multi-tenant migration. Gather dictionary stats before the migration. Don't do this on the migration day. Try to do this on the day before the migration. Dictionary check. There is a new package you can use, DBMS dictionary check. So AutoUpgrade can also do this for you. Very important thing, backup your database after the migration. So take a level 0 backup. So sometimes you can't wait until the level 0 complete. So you go live before the backup completion. So to restore this period of time, you can use the archive logs from your source database. It's called plugin backup. So you can export the Arman metadata from a source database and import on your new CDB. So please take a look on this package, DBMS PDB export Arman backup, and practice before the migration day. So if something happens on the migration day, you'll be ready to deal with it. What about Oracle RAC database? Well, there is nothing special. You just connect to one instance and plug in the PDB. And you don't need to set the cluster database to false. Back to you, Mike.
Thank you, Alex. Now, we discussed a lot about how to plug in, what to prepare, and so on. But there's one important topic we need to cover here, and this is what actually happens to your standby when you plug in on a primary. Because on the primary side, the plugin command and everything related to it gets recorded into redo, so the standby receives that. And now there are two options for the standby side. Either you do this with enabled recovery, or you defer the recovery. So let me discuss the two options and what the differences are. Enabled recovery means you create pluggable database on the primary when you plug in and you say standbys equals all. Now this means everything gets recorded into redo, the standby receives it, learns about the creation of the pluggable database on the primary side, creates it as well, and then looks for the data files. Once it has the data files, it then kicks off the MRP, the managed recovery process, and it will start applying redo to bring your new PDB on the standby in sync as well with the primary. And then your environment is right away protected. The other option is, this is the default by the way, the other option is you create pluggable database, but with standbys none on the primary. Now, the standby side still learns about the creation of the PDB, creates it, but as an empty shell, and then it does not look for the files, the MRP process does not kick off, and you need to take care now to restore the PDB on the standby later on. You can do this also individually if you want to. So let's say you have 3 standby databases, and you would like to run with enabled recovery for standby 1 and 3, but not for standby 2, then you could pass on a list, comma separated, or you could also say standbys equals all except maybe standby 2 here. In any case, you should always check in VDollar PDBs for the recovery status to be extra sure that all is done correctly. And when you use AutoUpgrade, what we highly recommend, then you can also specify the all, none, the list, or the except. But in this case, you need to do this in the config file of AutoUpgrade with the manage standbys clause. And there you can specify it. AutoUpgrade then builds the command exactly based on what you specified here. Now, enabled recovery is a little bit more complex because we need to do something before and we need to do something during the process. But the good thing is the standby is protected right away. And we can start with the production side immediately after plugging in. This is when you use standbys all, or when you pass on at least the list. And as I said before, this is the default. Now, when we look closer on a graphic here. This is my primary server and my standby server. I have non-CDBs on the primary, and of course then also non-CDB on the standby, because it doesn't work across the architectural concept. And of course, they have both their data files, and they are identical. A standby is a block identical copy of the production, a physical standby. Now we create our target CDB on the primary host, and then from that also the standby CDB. What happens now when we plug in? We plug in on the primary, and the plugin happens, and then propagates everything via redo, and the plugin happens on a standby as well. That's what I would typically expect, and that should be the norm. But when we do this, there's something we really need to pay attention to, and this is the SCNs. And if you fail here, you will have to do some manual steps afterwards. So be very aware of this part. On the standby, we turn off the apply, then we shut down the standby, we start it up, and then we turn off also if alter database recover manage standby database cancel the MRPO. When this has happened on the production, we shut down as well. We start up in mount modus. We flush the redo. We open the database now read-only. The read-only is really important here. And then we select the checkpoint change from the data file header. Let's go to the standby. And this number given us here is what we turn on now recovery until change. This is the checkpoint number we need to pass in here. And then we select again just to make sure that both sides are in sync. So they really must match. And then we create a manifest file, because in this case now the manifest file, as you will see, has the SCN or the checkpoint change number in it as well. And we want to make sure that primary and standby are exactly in sync here when we plug in. In addition, I would also recommend to monitor both alert logs just to be on the very safe side. Then we can shut down the standby, and from there on we can go a step forward. So the plugin happens now on the primary database. We plug in on the primary and we use the manifest file. And a manifest file contains all information about the data files. And how does the standby know which files to plug in? And here we have to differ now, again, because there are different options. You can have regular files, you can have OMF, Oracle Managed Files in file system, or you can be in ASM, which a lot of you certainly are. The most simple case is regular files. The standby just searches for the same file names in the same location as on the primary, unless you overrode this with DB file name convert, or you can also use the standby PDB source file directory for that. That's very simple, very straightforward. With OMF, it's not that much more complicated. Just one difference. The standby searches now for the data files at the OMF location, and this is guided by DB create file dest. So you move your data files then from non-CDB to the OMF location, or you create soft links. But ASM is a little bit more tricky, because the standby searches for the data files at the OMF location, DB create file dest, and this looks like on a slide before, right? But there is something to take care on. So let me elaborate that a little bit more. We have my non-CDB here on primary and my non-CDB on standby. This is where we start. So let's have a deeper look into v.data file and compare the file names to each other. Now we compare the file names, and unfortunately in ASM, it's the same file here for the users table space, but they have different names. Is that a problem? Sort of. When I create now the manifest file on my primary, and you create it always on the primary as I shown you before, and when we look into the manifest file, it's an XML file, then we see it has recorded the file name, of course, of the primary, not the standby. So Now let's switch to the CDB environment. My target primary, my target standby. I create pluggable database on the primary using the manifest file. And a manifest file lists now the location of the data files on primary. That's obvious, and we expect that, but there's no information about the files on the standby side. So the reader record says, hey, please plug in db_Boston data file users 273 and so on. But this doesn't work because the data file on the standby has a different name. It's db_Chicago and so on. What do we do? Let us check the OMF directory. So what do we find here? It's a different directory. This is where it starts. It's a CDB_Chicago PDB GUID is inside data file. What do we do? And this is empty. Let me try. Can I move the file in ASM? I tried that. Sorry. Need to tell you, there's no move command in ASM. So that does not work. We have a rescue here, and it's aliases. So it's similar to creating soft links. So we add an alias, and with this alias help, like a soft link, it can now find the file. This is the non-CDB standby data file. It's users.269, not 273, it's 269. And I create now an alias, and the important part is that it has the right directories and the right PDB GUID in it. The name itself does not really matter because you will see the standby scans all files in the OMF directory, and it looks actually in the data file headers, and therefore it will find a file. The important part is that it needs to look into the right directory. So what happens now, if I plug in and these aliases are in place and you create the aliases on the standby side, not on the primary side, because we want to plug in the standby files and we need to tell it the right directory. So the standby database scans now its own OMF directory for data files. It ignores the file names, even if you did a typo there, doesn't matter. It looks at the file headers and then it finds the aliases and the real file locations. And then it can also replicate the plugin operation on the standby. So here you see that it looks for a file like the one on the primary, and DB Boston is it for matching files. You really see this in the alert log, and then it deletes the managed file and adds the right file pointer, and there it is. Now it's plugged in. You see, this is the standard name it had before from the standby. It uses now the alias to find a real file. And Daniel would like to show you that entire process into a demo. So you saw it, how it works in theory. And Daniel, you turn now with the demo, please.
It's demo time. I have a 19C non-CDB that I want to upgrade to 23 AI with data guards. I'm on ASM and I want to reuse the data files. I have two sites, Copenhagen and Aarhus. My non-CDB is called DB19 and the container database is called CDB23. I will create ASM aliases in preparation for the plugin and upgrade where I am reusing the data files. I start on the primary system on Copenhagen and the environment is set to my 19C non-CDB. I've configured DataGuard already with the DataGuard broker, so I can use DataGuard CLI to see we have Copenhagen and Aarhus serving as primary and standby database. Then I set the environment to my container database. It's on 23, so I need to upgrade the database as part of the process, and it's an empty container database, no PDBs yet. I've used the broker here as well. Similar, Copenhagen and Aarhus, primary and standby database, all looks fine. Now I can do the preparations before the upgrade. This is my AutoUpgrade configuration file that I use for the analysis process. I specify my DB19 database, the container database, and the source and target Oracle home, and then I start AutoUpgrade in Analyze mode. The analysis completes fairly quickly. It's non-intrusive, so I can run it on an active database, don't worry. I check the summary report to see the details. Check passed, no manual intervention needed. All is good. I can proceed with my operation. So at this point in time, downtime starts. The first thing I do is to run the pre-upgrade fix-ups on my source non-CDB database. And I use AutoUpgrade for that. It'll purge the recycle bin, gather some statistics, and so forth. Then I can create the ASM aliases needed on the standby database for the plugin operation. So here I switch to the standby system on Aarhus. I set the environment to the non-CDB standby database. And I connect and find the GUID of my database. This will become the GUID of the PDB when I plug it in later on. And then I generate a list of all the data files on my standby non-CDB. Then I switch to Grid, still on the standby system, and I set the environment to my ASM instance. I connect and create a directory in ASM, which will become the future OMF location of my PDB. And as part of that, I need to specify the GUID. In that directory, I can create aliases for each of the standby non-CDB data files. In the future PDB OMF location, I have an alias name, and the alias points to each of the standby non-CDB data files in the non-CDB location. The next step is to recover the standby database to the exact same SCN as the primary database. So I start on the standby system and I set the environment to the standby non-CDB. I used a DataGuard CLI to stop redo apply in my non-CDB standby database. And then I restarted in mount mode if it was running in read-only mode. On the primary system, I set the environment to the DB19 database and I restarted into mount mode. Then I flush all available redo from the primary database to the standby database. So I'm moving all the redo to the standby database and I open the primary in read-only mode. I get the SCN of the data files on the primary database because this is important for the next step. On the standby non-CDB, I recover it to the exact same SCN as the primary database. And I also verify that the data files, in this case the first data file, is on the same SCN as on the primary database. All looks fine. Then on the primary database, I can move on and create a manifest file and then shut down the primary non-CDB database. Likewise with the standby. Hopefully we don't need those anymore. Because now I will move on with the plugin operation, which happens in the container database. I'm connected here to the primary system, and I set the environment to my container database, the primary container database. I use the create pluggable database statement to generate or to create the PDB using the manifest file, reusing the data file using the NOCPY option, and then I open the database in upgrade mode because I need to upgrade it as well. But first, I used DataGuard CLI to ensure that the plugin operation didn't ruin anything. I can see that redo apply is still running in the standby database. It looks fine. Validate database reports the standby is ready for switchover. It looks fine, but I want to do some extra checks. I move to the standby system, set the environment to the standby container database. And I can see that the PDB has been created here and the recovery status is enabled. So that's good. And the recovery process, the MRP process, is still running. It's apply and log. All is good. My plugin operation didn't ruin anything on the standby database. So I move on with the upgrade and the conversion. I'm on the primary host, and I have a new configuration file that I'll use for auto upgrade. I'm going to upgrade the DB19 PDB in the container called CDB23. Since the CDB is already upgraded, I just specify the same source and target Oracle home, and then I start auto upgrade in upgrade mode. It'll start to process the PDB and do the upgrade. I use the LSJ-A option to run the LSJ command over and over again. I'm fast forwarding a little. First the upgrade, some post fix-ups, and the job completes. Now the PDB has been upgraded to 23 as well. I connect to the container database and I restart the PDB in normal mode. It's technically still a non-CDB, but at this point the container database will automatically convert it to a PDB because of the alter pluggable database open command. I check for plugin violations. There are only warnings, so for now I'm going to ignore those. Let's have a look at the alert log of the container database. I want to see what happened when I opened the PDB. Well, here I can see that the container database automatically started the non-CDB to PDB conversion at the first open of the PDB in normal mode. I don't need to run the non-CDB to PDB script myself. The database does it for me. Let's connect to DataGuard CLI. I check that the standby database is still fine. It reports that it's ready for switchover. It looks good. But the best test is, of course, to actually perform a switchover. So let's do that. Let's switch over to the Aarhus site. That happens fairly quickly. Okay, no problems during switchover. That's good. But let's connect to the new primary database on the Aarhus site. It's the primary database. All looks good from here. And the DB19 PDB is opened, read, write, and unrestricted. All looks fine, even on the standby database after a switch over.
The real file. So you can move the data files afterwards into a proper OMF location, and then you can get rid of the aliases. How do we do that? So this is the location on the primary. So we plugged in, but you see the files still point to the non-CDB OMF location, not to any new or whatever. The database does not care. And honestly, we don't care that much either, but if you care, and humans might care, then you may want to move the files into their designated locations. How do we do that? So on the primary, it's pretty straightforward and pretty simple. You can use the alter database move data file command. So just issue that, and you see immediately, I do this for file 14 here, and you see it gets updated right away. This command copies the file, then drops the alias and the original file. So it does the cleanup, everything done. It requires the additional disk space because during the time of the move, there will be a copy created and it is a seamless flip. So no interruption, it's a complete online operation, but be aware of the extra disk space needed here. But how do we approach that on the standby? On the standby, the online data file move works only within the PDB and only if it's open. In order to do that, unless you have an active DataGuard license, you need to stop redo apply before you open the PDB. And you need a PDB open because otherwise you can't move the files. So be aware this requires time, disk space to hold a copy, but then it does the entire cleanup. So it removes the alias and it removes the original file once it has been completed. How do we do that? If you don't have an active DataGuard license, then you need to turn off redo apply here. You have your database, your entire standby database in read-only mode. Then you open the PDB in read-only. You switch into the container, like PDB1, and then you move the data files. And once you're done, you stop it. Then you start it up again here in a environment, we use the SRV-CTL commands. And once this is done, you connect to your DataGuard command line manager and you turn the apply on. This is the process if you don't have an active DataGuard license. If you have an active DataGuard license, then you can reduce the entire set to these commands. So there's no need to stop the database. There's no need to turn off the apply and such. You can just issue this online. Another option would be when you do know that you take a switch over once a month, for instance, then you repeat the steps once your standby becomes primary. That would be also an option in case you have no active DataGuard license, but want to avoid that stop and restart of the standby. And of course, the duration, if you have like 5,000 files, this may take a little bit. Because while you relocate the files on the standby side, the apply lag may increase. Let's say the entire operation takes 2 hours, then you have an apply lag. No worries, there's no data loss involved here. The redo transport is still active, but in case of now a switch over or a failover needed, you need to take into account that the recovery will take now longer. Your time will increase. Now we discussed everything works nicely and fine, but what happens in enabled recovery mode when the standby still fails to find a data file? If it fails to find a data file, with 21C and of course 23AI, we introduced a new feature. It's called PDB recovery isolation. So if you have active DataGuard and you turned on PDB recovery isolation, then the recovery for the specific PDB is disabled. In this case, it doesn't find all the files. The recovery proceeds for the CDB and all other PDBs, but except the one which doesn't find the file. Once the file is found, the standby automatically restores the data file. Actually, in this case, it doesn't even need to find it. It restores it from the primary and then re-enables recovery afterwards. So the PDB is protected after the auto restore has done. So basically, 2 things to remember. It's a 21 feature. And of course, 23, it requires that you have active DataGuard and you need to turn on PDB recovery isolation. And when you do this and you go through this process, and in the unlikely event the PDB standby does not find a specific file, it will ask the primary, get it over, and then restore it automatically. Why is this so important? If there's no such process, and this unfortunately happens until 19C, in such a case, the recovery halts. But not only for the PDB, it halts for the entire CDB. So this is a critical situation. Now we have an issue. So be aware of that. Yeah, and how does AutoUpgrade now deal with the entire process when you want recovery enabled? The current version as of now, as we speak here, 24.1, does not support plugging in with enabled recovery. That means the enabled recovery requires extra work on both the primary and the standby hosts, and so we must execute some commands. So you can use AutoUpgrade in specific steps, but you need to do additional steps manually. Therefore, this is a challenge, but we are heavily working on this. With that, I would like to hand over to Daniel to explain now the concept of deferred recovery, since we talked so much about the enabled recovery approach. Daniel, your turn now.
Thanks, Mike. A more simpler approach for your standby databases is to use deferred recovery. With deferred recovery, you need to restore the data files onto each of your standby databases after the plugin operation. Until you've done that, the standby databases do not protect your new PDB. If you want to plug into a container database that's protected by DataGuard, you use again the create pluggable database statement, but with deferred recovery, you specify standbys equals none. This tells the standby database that there is a new PDB, but it will not make any attempt to find the data files, so we have a PDB, but no corresponding data files. On the primary database, everything looks fine. We plug in, we reuse the data files. But on the standby database, we just have the PDB, no data files. If you use the show PDBs command, it looks fine on the primary database. The PDB will open read write. But on the standby database, the PDB is just mounted. This looks normal in a DataGuard environment, but if you look in the $PDBs view, you can see that the recovery status is disabled. This means that the MRP process will not attempt to recover any of the data files on the standby database. First, you need to restore all the data files from the primary database. You need to enable recovery and unline the data files. Not until you've done that will the standby database protect that PDB. This process of restoring the data files and re-enabling recovery, if you are on 21C or above, and you have active DataGuard, and you turn on PDB recovery isolation, this entire process is completely automated. The standby container database will see the situation and immediately start to remediate it. You still need to wait a period until the standby database protects the PDB. It still needs to recover the data files, but at least underneath the hood, it happens automatically. Whichever method you choose, enabled recovery or deferred recovery, it is extremely important that you know with standby databases and plugin operations, you need to check the standby database. We don't want you to jeopardize your DataGuard configuration. So know that you need to check the configuration, you need to test, and the best possible test is to do a switch over to the standby database. I recently worked with a customer that faced a similar migration. They had a fairly complex non-CDB database that they needed to migrate, and they had several standby databases connected. They were concerned about the complexity, so we worked together on their project. The customer is Swisscom, the leading provider of telco in Switzerland, and they are a pretty cool and innovative company. With me today is Tom Meyer from Swisscom. Hello, Tom. Can you share a few words about yourself and Swisscom?
Yes, my name is Tom Meyer. I'm working for Swisscom for the last 20 years. And Swisscom is the largest telecom provider in Switzerland. And in our team, we are operating a fleet of Exadatas with roughly 2,000 databases.
Yeah, we recently worked together on a multi-tenant migration of an important database. Can you share some details about it?
Yes, we have a pretty big database landscape, roughly 2,000 databases on engineered systems, mainly Exadata. And we migrated them all to multi-tenant and 19C over the last 2 years, except one, which was the Siebel core database. Mainly due to the fact that it's a quite complex setup, including 5 standby databases and a Golden Gate replication.
Okay, how did you deal with the standby databases?
We dealt with the standby databases during the migration in such a way that we always wanted to stand on 2 legs. That means a primary and a standby for disaster cases should be always available. And we did that with ASM aliases for the main standby database. The remaining standby databases, we restored them with recover from service afterwards.
Okay. Are there any learnings from your project that you would like to share with others?
Well, the learnings are that you need to test and test and test again, and you need to have a waterproof, rock-solid screenplay, and you have, in such a complex setup, you have to have like at least 8 eyes watching all the different logs and traces and potential failure sources.
Okay. Thank you, Thomas, for sharing the details on your project.
You're welcome.
As explained by Tom in the interview, they had their Siebel database that they wanted to migrate. It was a big database, and on average, they had around 3,000 active users, so of course, downtime was a concern to them. The database was fairly complex, 6,000 tables, almost 20,000 indexes, and a lot of other objects like lobs and partitioning and so forth. So it was too big and too complex to use data pump and transportable table spaces. They wanted to do an in-place migration to the single tenant architecture. As explained by Tom, they are using the entire Oracle stack. This specific database was protected by no less than 5 standby databases. Each one of the standby databases were running on the Exadata database machine with a 4-node rack database. To make it even more complex, they were also sending data to other systems with Golden Gate. They could immediately see that such a migration would be really complex, so they worked together with their business, trying to come up with a middle point. How can we reduce complexity, and what do we need to do with these standby databases? Of course, they were not willing to compromise the integrity of their database. So one of their DR databases, the main disaster recovery database, they bring that along with ASM aliases and reusing the data files. But the other ones, the auxiliary disaster recovery and the reporting databases, well, they could tolerate that those databases would not be ready at go live. They still have one database that could take over in case of any disaster. But especially the reporting databases that they had a little lower priority and they could wait with those. In total, the team did the migration with a downtime of 3 hours and 30 minutes, which is still within their downtime window. But the majority of the work in the maintenance window was actually related to the application and the Golden Gate configuration. The team at Swisscom estimated that if they only had to do the migration of the database with the standby databases, they could do it within an hour to 90 minutes. The non-CDB to PDB script ran for around 18 minutes. Tom already went over the learnings, but the key point here is really to, if you are facing a complex project, see if you can reduce complexity, do things a little different so you don't end up with a project that is way too complex. It is risky with complexity, so see if you can find a good middle ground. Speaking about Exadata, in the next part, Rodrigo will show you how you can do non-CDB to PDB migrations on some of our Exadata cloud offerings.
Thank you, Daniel. So a lot of people ask us, what if I have an Exadata in the cloud? How do I move to the multi-tenant architecture if I'm running in the Exadata cloud at customer or in the Exadata database service, which is the Exadata as a service that we run in OCI? So the answer is we can move it to the multi-tenant architecture, and it's very easy. All you have to do is using the tooling, the CLI command or whatever, or the UI interface, for example, to create a new empty CDB, or you can also use an existing one. And then you plug in and convert using the method of choice. So we always recommend using AutoUpgrade, but you can also use the manual method if you want. You can connect on the CDB and run, for example, create pluggable database from whatever, or even from a source database using DB-Link, for example. But again, we recommend you doing that using AutoUpgrade. And later, the tooling will automatically adapt the new CDB after some time. So in the past, on the previous version of the tooling, this was something sometimes not working, and you had to open an SR. But on the newest versions of the tooling, it's very well prepared, and it will auto-detect that new database that is in that CDB and appear in your interface as a new PDB. Okay? Also, EBS. What if I have a EBS? So the only requirement if you have EBS is that your EBS version is 12.2 or 12.1.3. Those are the two EBS versions that support the multi-tenant architecture. And in EBS, you need to go to the single tenant architecture, which means on that CDB, you can have only one PDB, which is the PDB that you're gonna be running the EBS database, okay? And as anything else in EBS, we always recommend you to follow the documentation notes specifically for EBS. So here we have a list of some important notes if you want to use the single architecture the single tenant architecture option for your EBS system. Okay, now let's say you have an encrypted table space in your database and you want to move to multi-tenant architecture. So how do we do that? So it's very simple. If you have an encrypted database, all you have to do is in your source database, before doing anything, you need to export your encryption keys. And how you do that? You run the administrative management command with the export key files. So this will export your keys to a text file. But of course, we will encrypt this text file for you. So you can also provide a password here. Actually, you must provide a password to encrypt your keys in these text files. Then you follow the same commands you had before. So you set your database to read-only mode, you generate the manifest file, then you shut down your database, then you go to your target container database, and you run your create pluggable database command, for example, using the NOCPY option here, and this is gonna read the manifest file. So after it reads the manifest file, now it's the time you need to run the administer key management import command, okay? So here, when we run the import, it's gonna import all the TD keys that were stored on that encrypted text file that you exported from your source environment. So basically, the steps are the same, but with two extra commands. One to export the keys from the source, and the other one to import the keys on the target. So that's simple as that. And of course, if you grow with AutoUpgrade, that we always recommend, that's all transparently in AutoUpgrade. So AutoUpgrade, when it executes, it's gonna need to run multiple commands like create pluggable database, alter pluggable database, and most of these commands, when you have a TDE enabled, the transfer data encryption, you need to provide a password to that commands. So how does AutoUpgrade handles that? Does it keep asking you all the time for the password? And the answer is no. So in AutoUpgrade, before running AutoUpgrade, you have two options to transparently handle TDE. One of the options is to store your keys using the secure external password store in both your source and target databases. So if you use this option, you don't need to provide anything to AutoUpgrade. And the second option is to add the TD key password in an AutoUpgrade key store. So what AutoUpgrade will do is ask you for those passwords, and then it's gonna securely encrypt those passwords and store those passwords in the AutoUpgrade key store so we can use it when it executes the create pluggable database and alter pluggable database commands, okay? It seems like a bit complex, but actually it's very simple. All you have to do is add this extra line global key store to your AutoUpgrade and then execute it. And AutoUpgrade will tell you what you need to do next, okay? So here, for example, when you run AutoUpgrade with mode analyze, and you have a TD encrypted table space on your source, it will tell you that you need to add the TD password of both your source and target databases. So let's see that in a live demo, which is much better. So starting the demo here, we have this database. It's a 12-2 database. We connect on it, and we can see that there is one encrypted table space. The user's table space is encrypted. This is my AutoUpgrade config file. And here we see that we are converting this DB12 to a CDB2, which runs in the release 19. And we have the global key store parameter here of AutoUpgrade set. Now, when we run AutoUpgrade in analyze mode, it's gonna run, and after a while, it finishes, and when we check the log file, so opening the log file, we see that pre-check failed. And why it failed? Because TD passwords are required. So we screw up a bit here. We open this file. And here we see the required actions. So what we need to do is add in AutoUpgrade the TD password for both the source and the target databases. Okay. So what I'm gonna do is I will load the password of my source database in the AutoUpgrade key store. So when we run this load password command, first it asks for a password. This is the password to encrypt the AutoUpgrade key store. That's not the password for your source or target TDs. Now I will add here, for example, the password for my source TD. Okay, so I'm adding the password, and now I will save it. Okay. And I will also convert the key store of AutoUpgrade to auto-loading, so I don't need to type the AutoUpgrade key store password any longer during the execution. But you noted that I haven't typed the target database key store, right? Why? Because here I will use the second method that I showed on the slides. For this one, I will use the secure external password store. So it's not configured. I will do alter system to set the key store location. I need to bounce my database instance. And after it starts again, I run the command to create the secure external password store. Okay, now I will finally call again AutoUpgrade in the analyze mode. And let's see if we get an error again. So it's loading the key store because it's an auto-loading wallet. Otherwise, I would need to type the AutoUpgrade key store password here in this step. Okay, and after a while, it finishes. Now checking the log file. Okay, the pre-checks finished with success. So no manual intervention needed, meaning I'm ready to go with the deploy mode. So now I call again, but with the mode deploy. And again, it loaded the key store automatically because it's an auto-loading wallet. And now all I have to do is keep tracking the execution. And after a couple of minutes, my job finished. And if I connect now on the target CDB, which is the 19C, I can see my database was fully upgraded and converted. And if I change to it, I see it's open in read-write mode and the encrypted table space is there. Did you see how easy it is with AutoUpgrade and encrypted table spaces? It's not hard as it looked. Now it's with you, Mike.
Thanks, Rodrigo. We are almost at the end. There's just one thing we need to discuss. In the unlikely event of loss in cabin pressure, oxygen masks will automatically drop from above, and so on. So what do we have to do? What are our rollback? What are our fallback options? First of all, to be clear here, the PDB conversion is irreversible. And not even flashback database would help us here. There's no way. So we need to find ways of going backwards for two specific cases. Case 1, something fails in the process. Case 2, we decide after going live. So before go live means you haven't started the application yet on a new environment. No changes are in. What are your options? You can leave a copy or you restore. Whereas we think leaving a copy is the better option. So you would use create pluggable database and then the copy command. Refreshable clone PDBs would be an option as well, but keep in mind that doesn't get propagated to the standby, so you have to always set up the standby afterwards. You could incrementally roll forward data file copies, or you could use a standby, an additional standby, and leave that behind. What do we mean with leave a standby database behind? Let me give you an example here. This is our environment. We have 1 primary server, 3 disaster recovery environments. And what we do is, when we plug in the source non-CDB, you see we have the 3 standbys. We plug in only one of the standbys, not all of them. So we leave the standby on server 3 and 4 behind. The plugin happens reusing the data files on server 1 and 2. But in case of a disaster, if an error happens, we could fail over to the still kept non-CDB standbys. And if all goes well, which should be the norm, then we rebuild the standbys afterwards on server 3 and 4 with a duplicate for standby, simply with Armin, because we have 1 standby already in shape. So this means leave a standby behind. It's like your secure copy. You could fall back, or better, roll back, not fall back, in case something happens as part of the process. But we haven't started the application yet. The other option, arm and restore, of course, would work as well. In case you have no standbys, this is the best option. But keep in mind, restore your backup, recover it, just for a test beforehand, just to make sure. Now, what are the fallback options? Fallback means we went live already. We went live on Monday morning, and on Tuesday afternoon, we decide we need to go back. This happens very, very rarely, but still we should be protected. So if you want to go back to a non-CDB environment, because you came from a non-CDB, you went to the CDB architecture, you decide you want to really go back to non-CDB, then data pump is your friend. Another option, if you haven't upgraded, transportable table spaces. Transportable table spaces can go same version or higher version, but never lower version. And if you require minimal downtime for that, then Oracle Golden Gate needs to be used on top of either technique. An alternative option to fallback from an upgrade and PDB conversion would be if you upgraded and converted from 19C, for instance, to 23 AI, then you can go back to 19C and stay multi-tenant. So you came from non-CDB, you went to the PDB, and now we say, look, you can go back to 19C, but not to non-CDB. You go back into a PDB. And this is simply done with a downgrade. So in the 23 AI PDB, you run the cut downgrade script, you unplug it, you plug it back into a 19C CDB environment you provided, and then you run cut reload. This reloads the PL SQL engine, the database, and then recompiles. Interestingly enough, that usually runs faster than the upgrade in terms of the timing. But in order to do so, remember that your 23 AI CDB must be created with compatible 1900. If you created it with the default compatible setting, then you can't go backwards. If you really insist and you want to go back to 19C non-CDB, then you could still use the option 1, and then from there you could use transportable table spaces back into a non-CDB environment, or alternatively directly using data pump down from 23 AI directly to 19C non-CDB. Don't forget to use the version parameter. Check our virtual classroom seminars about data pump. There we discussed that, and we have an entire fallback and rollback seminar. How low can you go? And please check this out. Now it's time to wrap up, and Roy will close the seminar.
Well, as usual, we covered an awful lot in the couple hours that we had with you. Everything from the multi-tenant architecture to creating, to migrating, to fallback options. So basically, it's time to wrap up for today. Couple words of advice to leave you with. One, if you've never used multi-tenant before, like anything else, start small, start simple, learn the architecture. It's new. If it's new to you, take it easy, start with a simple database, and give yourself the time to learn to adjust not only your mindset, but your maintenance scripts and everything else that you might need to look at for your environment. And only once you're comfortable doing this on a day-to-day basis with those smaller databases should you progress to your bigger, more important mission-critical databases. So that was everything you needed to know about multi-tenant, right? Well, maybe not so right, because all we talked about was how you get there and what your fallback options are. We didn't get to talk about all the day-to-day operations like patching and dealing with data guard and upgrades, and what do you do with your maintenance scripts, and how do you connect to a PDB if you've got multiple PDBs in the same container, and how does rack affect PDBs? And yeah, we have a whole part 2 coming in June just to cover all of that. So we really hope that you found this interesting enough that you'll come back for part 2, which is kind of the more advanced topics, but the ones that are going to affect you on a day-to-day basis when you're managing and using multi-tenant databases. So last word, it's always better to fail on someone else's system, right? And we have a system for you to come and fail on. It's called Live Labs. We have our multi-tenant lab environment that you can use for free, and you can play around with multi-tenant migration. You can dig into the dictionaries. You can do whatever you want in there. Doesn't matter, because you can just throw it away, reprovision it, and start over. It's a great place to not have to buy hardware, allocate stuff, go to your purchasing department. It's there on the web for you with guidance and a whole set of steps to follow for your multi-tenant migration. I would also be remiss if I didn't mention our 30+ hours of content. And you'll notice that we're refreshing it. Like, look at episode 4 there at the top of the screen. We covered multi-tenant 3 years ago, but you know what? There's been a lot of change in 3 years. So we continuously refresh and enhance our content, just as the Oracle database sees enhancements and new features and new releases. We'll be back with you in June for part 2 of multi-tenant, but you might have other topics on your mind, like the previous one that we had on cross-platform migration with the new V5 migration scripts, or deep dives into auto-upgrade features, you name it. It's all there in our video library for you. Now, if you don't have 2 hours to spend watching videos, you might want it in more bite-sized chunks, and you can go to the YouTube channel, the Oracle Database Upgrades and Migrations channel. Join the 4,000+ subscribers there, and I think you'll find a lot of useful topics. It's a great place if you just want to refresh yourself on that one topic. Like, it might be something like, how did they say that I could do a rolling upgrade with DataGuard again? What are the high-level steps? And you'll get a 3-minute video or so on that. Last word, thank you. Thank you for spending your valuable time with us. Thank you for viewing our content, for amplifying it if it's useful to you. So from Alex, Rodrigo, Daniel, Mike, and myself, a collective thank you for all of our users, our customers out there, and we hope to see you again soon. Thanks.
To the next level, upgrade that Oracle. Feeling like a rebel Oracle, yeah, we on the rise. Multi-tenant CDB, open up your eyes. Now we on the move. like never before. Upgrade in the database, gonna explore cool features flowing like a river so wide. Gonna make that BDB sing worldwide. From the humble start to the top we go, higher, faster, stronger, don't you know? Oracle database, you're my number one. With that Multitenant CDB, we've just begun.